Our learning target says I know what a limiting reactant is and how to use it to calculate theoretical yield. So you're going to need to know how to determine what that limiting reactant is, how to determine how much excess you have left over, and the amount of product based on that limiting reactant. So the limiting reactant is the reactant that is used up first in the reaction. The excess reactant, you will still have more of it left over. You've got more than enough than you need in the reaction. So let's look at an example. If you're going to start your own sandwich shop, notice it's spelled all fancy, and your specialty is your superhero sub sandwich. So here's your recipe. 2 slices of bread plus 4 slices of ham plus 4 slices of tomato plus 3 slices of roast beef, 2 slices of turkey, 10 pickles, 13 pieces of lettuce, and that gives you 1 sandwich. Now, being new and all, we still got some learning to do. So this is what you have in your inventory. Okay, 10 bread, 30 ham, 8 tomato, 15 roast beef, 18 turkeys, 100 pickles, because you know they come in a big jar, and 30 pieces of lettuce. So if this is your inventory, how many sandwiches could you make and why? All right, so if we looked at each thing individually, if we have 10 slices of bread, we could make 5 sandwiches because each one takes 2. If we had 30 pieces of ham, we could make 7 sandwiches because each one takes 4 slices of ham. And we would have some left over. We have 8 slices of tomato. Well, it takes 4 for the sandwich, so we could only make 2 sandwiches. If each one is 3 roast beefs and we have 15, we could make 5. 18 turkey slices, we have 2 per sandwich, so we can only make 9 sandwiches there. For the pickles, we could actually make 10 sandwiches, and for the lettuce, we could also have 10 sandwiches. So the maximum number of sandwiches that we could actually make is going to be 2 if we follow this recipe, because we only have enough tomato to make 2 sandwiches. That tomato is our limiting reactant. Everything else is in excess. We have more than we need, okay, and you're going to have some left over. So we could figure out if we could only make 2 sandwiches, we would only use up 4 pieces of bread, so we'd have 6 pieces of bread left over. So we're going to do this using our stoichiometry. So we have a problem here, and it says you're in chemistry class. I give you 25 grams of lithium and 30 grams of bromine. How much lithium bromide would you get? So here's our balanced equation. So we start with 25 grams of lithium. Oh, sorry, I forgot to circle. Here's 30 grams of bromine. We are looking for grams of lithium bromide. So I need my conversion factors because we're dealing with grams here. I need my molar masses. I'm going to convert my 25 grams of lithium to moles. I'm going to convert my 30 grams of bromine to moles, and this is what I get. So when I look at the amount of moles, here's where I can start to look at what my limiting reactant is going to be. Most of the time, the one that is the smaller amount of moles is going to be your limiting reactant. Okay, so this is what we're going to use as our given. Okay, and we are going to base everything else on the smallest amount. Okay, so we're going to use this one to complete our problem. So what that means is that to do our fraction, we're going to put a 1 on the bottom of all our fractions because we are using bromine. So the top of my fraction is going to be 2, 1, and 2. Now here we're going to, remember we lose, so we have negatives, and we gain, so we have positives. Now we're going to multiply each one of these by our 0.188 moles. So now when I do my math, okay, if I start here, 2 over 1 times 0.188 gives me 0.376. But now that's not my moles after. Okay, I started with 3.602 moles. I used 0.376 moles, and that's going to tell me how much lithium is going to be left over. It's 3.226 moles left over. Now for bromine, 1 over 1 times 0.188 does give me 0.188. So if we subtract there, we do get 0. And here we are going to add 2 times 0.188 to 0. So we get 0.376 moles of lithium bromide. Okay, so our limiting reactant here is our bromine. Okay, so Br2 is my limiting reactant. It is used up first. Okay, so my lithium is my excess reactant. I have some of that left over. I have 3.226 moles left over. I'm going to produce 0.376 moles, but now notice I do want that in grams, so I do have to do that moles to grams conversion. So that's going to give me 32.7 grams of lithium bromide produced from 25 grams of lithium and 30 grams of bromine. Now if I want to calculate how much of my lithium is left over, I do need to take that to grams, okay, as well. So we could change 3.226 moles into grams using our molar mass. Let's look at another example. Okay, so we have how many grams of barium sulfate will be formed from 200 grams of barium nitrate and 100 grams of sodium sulfate. So there's what I'm looking for in my problem. And then it says if 155 grams of barium sulfate were produced, what is the percent yield? Alright, so remember for percent yield I have to have actual and theoretical. So this 155 grams is my actual yield. Okay, so I'm going to have to calculate my theoretical yield for my barium sulfate. Now notice I have 2 reactants, so I am going to have to convert each one to moles. So 200 grams of barium nitrate converted to moles is 0.765 moles. 100 grams of sodium sulfate converted to moles is 0.704. And of course we start with 0 of our barium sulfate. So because our 0.704 is our smallest, that's the one I'm going to use to complete my problem. Okay, so because there's a coefficient of 1, we're going to put a 1 on the bottom, all of our fractions. So we're going to put a 1, a 1, and a 1 on the top because of our coefficients. And we're going to multiply by 0.704 for each of those. So we lose our products, our reactants, we gain our products. So here for our barium nitrate, we would do 0.765 minus, 1 over 1 times 0.704 is 0.704. So we're going to end up with 0.061 moles of our barium nitrate. We're going to lose all of our sodium sulfate, and we're going to gain 0.704 moles of barium sulfate. So our limiting reactant here is our sodium sulfate. So limiting reactant is Na2SO4. The excess reactant is our barium nitrate. Okay, and now to actually get our theoretical yield, we're going to have to convert moles to grams. And when we change our 0.704 moles to grams, we get 164 grams of barium sulfate. Now this is our theoretical yield. Okay, so our first question here, what is the percent yield? We are going to use our formula, so 155 grams over 164 times 100. That's going to give us 95% yield. Okay, And then our question says, what is the limiting reactant? So we answered that, our sodium sulfate. How much excess reactant is left over? So we have to change our moles to grams for our barium nitrate. So when we do that, we get 12.2 grams of our barium nitrate are left over. And we have answered all of our questions. Now let me show you what happens if you pick the wrong reactant. Okay? Because every once in a while, it's a very small percentage of the time, the smallest number of moles, because of the mole fractions, will actually not be your limiting reactant. So let's see what happens if you pick the wrong one. Okay? Now again, this is what's going to happen if we picked the wrong one. Let's say we picked 0.765 instead of 0.704. Okay, so if we did that, we would use our fractions. Again, we would have a 1 on the bottom. We still start with 0 here. Okay, we would have a 1 on the top here, 1 on the top here, 1 on the top here, because all the mole ratios are 1 to 1. We would get 0.765 to multiply by everything. Okay, so 0.765 minus 0.765, of course, is 0. Now look at what happens here. If we do 0.704 minus 0.765, that's going to give us a negative 0.061. We can't have a negative. Okay, so if your fraction times your moles ends up being more than your moles, you've picked the wrong one, and you're going to just have to erase and go back and use the other one. So that's what happens if you pick the wrong one.